Hey there! Do you remember this data lake thing that was present in both architectures like modern data warehouse and data lakehouse? So probably it's a good idea to have one in our design as well. But actually, what features should a data lake have? And is there a service in Azure that we could use as a data lake? So let's find out. Now, this data lake thing, right, that we would like to have. So let's start by revisiting our basic BI flow, just to think why we would like to use this data lake. So it all starts with data sources, like always. And you should remember by now that in case of big data that probably we will have to deal with, we might have different types of data. Different kinds, like we might have structured data. Structured. For example, some database. And this data is considered structured because it has a well-defined structure that we know upfront. So in case of database, we know exactly what tables are there, what columns each table has, what are the data types defined for each column, and so on. So basically, we know what to expect from this type of data. But apart from this structured data, we might have different types. So for example, we might have files, like XML files or JSON files that are considered semi-structured. And this is one of the features of big data, this variety thing, a variety of data sources. So semi-structured data. Semi-structured. So in this case, we have the data that doesn't really fall into a table. So we know how a valid JSON should look like. We can validate given a file whether it's a correct one, but we don't know upfront what data will be stored, how many nesting levels will be there. Fortunately, there are some elements within those files that help us understand its structure, like tags or some metadata. And finally, what we might have is completely unstructured data that is even more difficult to store in databases. For example, we might have some movies, some video files, and we'll call this unstructured data. For example, let's say that we are developing a new system to host videos, and we just need to store those movies. So this is a valid data source. Anyway, all of these data types, let's just aggregate them and call data sources. And in real life, most likely you won't deal with all of these data types in the same project, but pretty often you will have structured and semi-structured data together in a single project. And then, if you recall this basic BI flow, you should remember that one of the first stages of data processing was this extract stage, that we just want to grab the data from the source and store it somewhere. And to be able to do this, I had this storage layer presented in my initial diagram. And now, in the past, when we used this traditional relational data warehouse approach, we would use just a database as the storage layer. So we would have tables with columns, data types, just fixed schema. And for some time it worked, as long as we had to process structured data only. But then in time, as more and more types of data started to appear, it became difficult and more time consuming to do this. So it turned out that this approach with fixed schema, it isn't that agile. it isn't that fast, and we need to have something different. Secondly, when it comes to this fixed schema, to model our data in a correct way, we have to understand the data. And quite often, we have to know upfront what questions this data is to answer. But in real life, it might be the case that we have end users or subset of end users that doesn't really know what to do with the data. There's just a new source, and what they want to do is just to take a look at it, to see what's inside. They want to start playing with this data. And then once they familiarize with it, then they will know what to do with it, how they would like to be present in the final solution. So they might start thinking, oh, now I know what this data has. So now I know what kind of questions we might answer with this data. But those users need this early access to the data that in case of relational databases is rather not possible. So at the end, what we did was to switch from this traditional ETL approach, and ETL stands for extract, transform, and load, those three stages that we were doing in the past. Like we were extracting data from the source, we were transforming it on the fly, for example, using SQL Server integration services or just SQL statements, and we were loading the data into those fixed tables. But this approach, as I said, it doesn't really work right now. So what we did was to change the approach into ELT one. So we switched the order of T and L. So basically it means that yes, we start with data extraction, but then we are not transforming the data in any way. We just dump it somewhere to some storage location as files, like here. So we would have some files in our storage location, and that's it at this moment. So we could grant access to those set of users, like data scientists, to start playing with the data. And of course, at this moment, this data might have quality issues, and probably it has. But at this stage, this is fine. Everyone is aware that this is just a raw data, not processed, right? And then once the data landed in our storage location, we might do some transformations. We might start to process it. We might want to model it somehow, just to answer those questions. So that's what this ELT approach means. And to achieve that, we need this data lake thing. And actually, switching from those relational databases into a data lake as a storage layer, it also changed our mindset when it comes to data storage and data processing. Because in the past, we were just grabbing the data that we need to answer some questions, which was fine, but it also might result in a situation when we modeled our data that answered some business questions. For example, a business might wanted to have sales data aggregated by continent, by Europe, Asia, Americas, and so on, because that's the scope and the granularity they wanted to see. And that's fine. But one day, if they come to us and say, all right, but actually I would like to have the same data aggregated by country, so more granular than previously, then we would say, sorry, we can't do this. We already transformed this data. So the data that we already processed is gone. We don't have the source data anymore. Maybe it was modified in the source. Maybe it doesn't exist anymore there, right? So in some cases, in the old approach, we might not be able to answer new questions because of the data that we already transformed. For new data that we will start loading from this moment, then no problem. But for the existing data, it might be an issue. In data lake approach, it changed. So basically, here we want to grab as much data as possible and just store it in a data lake, because data lake is cheap. And I like this this way of calling a data lake like a drawer. So I have a drawer in my desk, which I use to keep some spare parts, like some old bolts, screws, some cables, some mobile chargers that I no longer use, but I keep it just in case, because one day maybe I will need this part and then I will have it. And we have something similar with data lake. We just store data, all data that we have, because one day we might want to use it. And if that day comes, then the data will be already there, just waiting to be processed. So that's a change of a mindset compared to the old times. So now you should see that this data lake thing, actually, it's quite a good thing, and we might want to use it. But let's actually think about the features that data lake should have to be usable. So let's think about this. Features of a data lake. So obviously it has to be able to store files, right? Because that's the key requirement. We want to store our data in a data lake as files. So we can just grab anything from the source and just store it as file of any type, any size, any structure. This way, the ingest process, extraction process, is very fast and very easy. So this requirement, store files, it satisfies this variety thing of a big data. Then we want our data lake to be scalable. Again, think about the big data, about huge amounts of data that we might need to process. So our data lake has to be able to store 1 terabyte of data or 1 petabyte, depends how much data we have. We just can't run out of disk space in a data lake. So this scalability is all about volume of our data. And volume is a feature or a key characteristics of big data. Then we want our data lake to be cheap, especially if we are going to store huge amounts of data, massive amounts of data. It cannot be expensive, because otherwise no one would use it. So again, this is all about volume of our data. Next, you want to have great performance of data access. Great performance. So basically, whether we want to write data to a data lake or read data from it, it has great throughput. Let's say we want to have 10,000 connections writing at the same time to the data lake, and we have to be able to do this. Or maybe we want to stream a movie from our data lake. Again, that has to be supported. So this high performance is about velocity and volume of our data. Next, we want our data lake to be reliable. So basically, if data is our most valuable asset, and you might heard this term that data is new oil or new currency, and if we store this data on a data lake, then we just can't lose this data in case of some hardware issue. And obviously, at the end, this cloud thing, it exists in a data center somewhere in a physical location. So it uses a physical hardware that might fail from time to time. But when that happens, we just can't lose our data. So there has to be some mechanism built in that will protect it from such kind of failures. Then it would be great if our data lake exposed a REST API or some other type of API which we could use to connect to it, to write the data to it or to read data from it. And it's because, alright, if we have some services in Azure, many of them probably will have some connectors built in that will allow us to connect to a data lake. But how about some other components that we will develop outside of Azure? Maybe we'll have some C# application that has to connect to our data lake. And then this REST SPI might be a lifesaver. Next, we want this data lake to be hierarchical. So basically, we want to have a possibility to organize our files inside the data lake into some structure, into folders and subfolders, just to be able to not end up with a complete mess and apply some performance and improve, apply security and improve performance. So this structure thing is really important. Then we want our data lake to be secure. Again, this data that we store in a data lake has huge value. So we have to be able to secure it in a proper way. And it involves both networking stuff, like setting up some firewall that will define from what network we can connect to the data lake, or even setting some access to specific files, specifying who can read from given file or who can modify given folder. And finally, we would like this data lake thing to be Hadoop compatible. And if you recall from the previous video, Hadoop was this framework used to process big data, set of applications. And basically there is a lot of applications out there or tools that are able to process big data, and they use this Hadoop framework. And if our data lake can understand it, then it means that we could use it as a storage layer, which would be great. All right, so basically these are the features we would like to have in a data lake. So let's try to check if there is some service in Azure that we could use as our data lake. So let's jump into a Azure portal, and if I start typing data lake, then we might have some hints like data lake analytics. No, that's not our case, don't use it. Data lake storage gen 1. It sounds promising, but no, that's the generation 1. Forget about it, don't use it. Data lake houses. No, it's not our case, but storage account. That's what we want to use. So actually, let me create a brand new storage account, and then we'll discuss how it looks like under the hood. All right, so as always, when we provision a new service, we've got to select some subscription, resource group, and then I've got to provide a storage account name. And this name has to be globally unique. That's why I used this strange name. And it has to be unique because that name becomes a part of its URL, and we'll be later able to access that data by using URL, and just it has to be unique. Now, there is a lot of other options available which we could set when creating the storage account, but for now, let's just go with defaults. We'll get back to them later. So let's just review if everything is correct, and let me create the storage account. And in the meantime, let's go back to our whiteboard and let's think about storage account. So, storage account. storage account is here. Storage account. What we have inside this thing and why is it so cool in our cases when we have to deal with this big data analytics. Alright, so the storage account should have been already created. It was, and if we take a look at it, you will see in the overview pane that actually it has 4 services under the hood. So we have Blob service, we have file service, queue service, and table service. So one type of storage account service has actually 4 sub-services, and let's discuss each of them. All right, so let's start with this Blob service. So Blob. And now, Blob service is pretty simple. Basically, it is used to store files, and Blob stands for binary large object, which simply means a file. So in our case, it means that we might have a storage account with this Blob service. So let me just write it that this is a Blob service. And within this Blob service, we would store our files, because that's what Blob service is all about. Like we might have some CSV files, we might have some Excel files. Basically, any type of file would work. JSON, movies, and so on. There is basically no restriction when it comes to the type of files we could store. So let's think about those features that we just defined that data lake should have, and let's analyze whether this Blob service meets all of those requirements. So first of all, does it store files? Yes, that's the key functionality of a Blob service, to store files. Secondly, is it scalable? Yes, it is. We can store a lot of data. It is scalable. Is it cheap? Pretty much. And we didn't go into pricing yet, but we'll do this. But you have to believe me that yes, Blob is pretty cheap. And actually, let me move those features a little bit so it would be easier to see all of this stuff. All right. Next, how about high performance requirement? And yes, Blob service is pretty much performant. So high performance, again, we can check that it works. Is it reliable? Yeah, it is. And again, at this moment, you just have to trust me when I say this. We will analyze that deeper in one of future videos. Does it expose a REST SPI? Yes, it does. So we can access our blobs, our files stored inside a Blob service, or Blob storage to be more precise. How was it called in a UI? Oh, Blob service. So we can just have it as Blob service, just to have the names consistent. Now, how about this structure and hierarchies? Can we create them? So what I would like to have is like this. So again, let me draw our Blob service, and let's say that we would like to have a structure like this. So we have a root of our blobs. Then I would like to have two directories, two folders. Let me call them container1 and container2. And container, in the context of Blob service, is just this top level folder. So that's a name. So simply, containers are just folders. Now, within our containers, what I would like to have is to store some files, like this. And actually, let's create this in Azure Portal. So let's go back to Azure Portal. Here, I will use storage browser. Let's go to containers, these blob containers. That's what we want to use. Blob containers. Let me create a new container. And just to recap, container is just this top level directory. We already had one called $logs, but we can leave it for now. So let's create this container1 container. Let me create yet another container at the same level. Container2. Great. Then let's go inside the first container we created and let's upload some file, some blob, to see whether this basic functionality works, whether we are really able to store files. And if everything works fine, then we should be able to do this. So I have some sample file prepared, some txt file, which is pretty small, it has like 1 kilobyte. And let's upload it. And yes, the file is there, right? Pretty much it works. So let's go back to our drawing. So we just tested that this path works, that we can create a container which has files stored inside. But what if we would like to have more levels in our hierarchy? For example, we would like to create a subfolder inside our second container and then store our files in it, just to have a little bit more organized structure. So let's see whether this is possible. So let's get back to our Azure portal. Let's move to the second container, container2. And here at the top, you should see this Add Directory option, which looks that this is what we need. So let's click on it. And actually, this help says that it is creating a virtual directory. And it doesn't really exist until we create some files inside. So what does it mean? So let's create this virtual directory. Let's call it subfolder. And we can see that it was created, or at least it looks as if it was created. But now, instead of creating new file inside it, let's just go back to the second container, like this. And actually, our directory disappeared, because actually it never existed. We didn't create it. It was just a virtual thing. So let me create it one more time. But this time, let's upload some file to it, just like the message explained that this directory would not exist until we upload something to it. So let me upload the same file as previously. It went fine, and here now we can see that the file has been uploaded. And if we go back to container2, we can see this subfolder. This time it is visible. So you might think that everything works. We created this subfolder with some files. But actually, that's not the case. And in case of Blob service, we cannot have those hierarchies. The structure is completely flat. And what I mean by this? The directory, this virtual folder we created, it doesn't really exist. It's just the UI Azure portal that was kind enough to show us as if this directory existed. But in fact, those files that we created here, they had this subfolder as a part of its name. And it was just UI who was able to parse this name and display the paths as if this subfolder existed, but it doesn't exist. So in case of Blob service, we can have containers, those top-level folders, and then files inside them. We cannot have nested directories, which is a blocker for us, because one of the key requirements for our data lake was to have this structure, and it's not fulfilled here, which pretty much means that Blob service in this shape cannot be used as a data lake. Bad luck. So let's move on. And let's try to find some other service. Maybe there is something better that we could use. So we discussed blobs. The other service inside the storage account we have is called tables. Table. So it should be visible here in the overview. We have table service. So that's the one that I'm talking about right now. So what is this table service? So basically, its main use case is for NoSQL approaches. And now I know that this NoSQL, it might sound like yet another buzzword. In this case, it means that we want to deal with data that doesn't really have a fixed schema. So our data is schemaless. Schemaless. Great, but what does it mean exactly? So if you think about traditional databases, relational ones like SQL Server, what we did in there was to create some tables. And those tables had some fixed schema. For example, we might have an order table that would have ID column of integer type. We would have customer ID, some sale date, and so on. We have the schema defined up front. Then we might have some other table, like customer, that again has a fixed schema. And those tables would be just connected using a foreign key relationship to define that a specific order was created by specific customer. So that's what relational databases are all about, those relations between tables. And it works fine, this approach. It proved to be working for many years. But actually, it doesn't always work. So let's think about a scenario in which our data or structure of our data changes quite often. So for example, let's assume that we have a shop, online shop that sells huge amounts of products, different types, different categories. And as you can imagine, different product categories might have completely different properties. For example, if we shall sell shoes, then it would have a completely set of properties than food, or pens, or fridges, or whatever type of products we would sell. And now, to model those different types of categories, product categories, we could either, using relational databases, we could create a different table per each category that would have just the columns that make sense in the context of a given category. Or we could have this sparse wide table, or we could have this key value per approach. But actually, none of them is perfect, because relational databases were created for different use cases. And if we expand our business rapidly, we add new categories very often, then just creating new tables with new columns, it would be too slow. So that's where those NoSQL approaches prove to be useful. So in our case, this table storage, table service inside storage account, is an example of a key value pairs. So this is simply this. Table is a collection of key value pairs. So how does it work? Let's say that I would like to model, I don't know, employees maybe. So for each employee, I would define a set of properties, those key value pairs, that I would like to have. So for example, the first person that I would be modeling would have a property called name. And for example, it would be Piotr. I would like to add a second property, like age. That would be set to 41. And those two properties, they create together something called entity. Entity 1. And you can think of entity like something similar to a row in traditional databases. Then I would create yet another entity, entity 2, that might have a completely different set of key values, key value pairs. I could start with a name like Paul, so the same property as we had previously, but then I might create a completely new one, like gender. That would be set to male. Then I might set height property. Whatever makes sense in context of our business, like 180 in centimeters. So this would be our second entity. Entity 2. And the collection of those entities together, they create our table. So that's how it looks like. And actually, let me show you in the portal how to work with those tables. So again, I would go to a storage browser, but this time I will go to tables, this feature. Then let me create a brand new table. Let me call it employee. And inside this table, let me create those entities. So I would use this add entity button. And now for every entity, I have to set these partition keys and row keys that are used to identify given entity. Let's skip them for now, it's not important. At least not at this moment. And let's add our properties. So what we had in our diagram was name of string type, that for the first employee would be set to Piotr. And then I would have age property of type int set to 41. And that's the first entity, first row. Let's call it this way. Now let me add a second entity. But this time, this entity might have a completely different set of those properties, those key value pairs, because there is no schema. Remember, this table is schemaless. It's just a collection of key value pairs. But actually, I would like to have this name property as well. Let's call it let's set it to Paul, but the age, I don't want this, so let's remove this. And let's add gender, set to male, and yet another one, like height, that would be integer 180. So that's created. And now you can see that we have two entities created. And I know it looks as if it was a table, but that's just because Azure Portal displays this data as rows and columns. But please be aware that actually in case of our first entity of Piotr, it doesn't have those gender and height properties. They simply don't exist. It's totally different from our relational databases, in which this Piotr row most likely would have those gender and height columns that would be set to null. But here, it's a different. Simply, they don't exist, those properties for Piotr. Likewise, in case of Paul, we don't have this age property. So you can see that this table, it actually doesn't have a schema, which makes it very flexible. We can add whatever properties we need, and it doesn't take time to design this table. But obviously, when we will be reading this data, then we might have to write our queries properly, just to make sure that we are reading the data in a correct way. Now, this table service inside storage account is pretty basic one. So if you need some more advanced features, more advanced database of this NoSQL type, then Microsoft has a different service created for this purpose that is called Cosmos DB. And actually in the past, this Cosmos DB was in the scope of DP203 exam, but it's not longer the case. So you don't have to worry much about it. And actually, for the exam, you have to focus on the Blob service only from all of those services that are available inside storage account. But I believe that it's good to know that they exist. Alright, so we know that table storage is actually used to store our entities, those key value pairs. So it can't be used as a data lake. So we've got to move on and check yet another part of our storage account. So the third service that we have inside the storage account is queue service. Queue. And now queues are pretty simple. They are used to store messages. That's the basic use case. Store messages. And when we think about a real life use case, then alright, so I can store messages inside the queue, but how to use it? When? And one of the use cases that are used for queues are when we want to decouple some components of our application. Decouple. And let me explain how it might work. So let's assume that we have an application that has two components, component A and component B. Whatever they are, it's not important at this moment. And let's also say that component A sends some requests to component B to do something and expects some response. Now, everything works fine when there are no issues. But what if component B is under heavy load? When there are so many requests coming from component A that B is not able to process them in a timely manner. It might result in timeouts, which is bad. So there might be some requests not processed by B. Or what if there is some network issue between A and B? Again, those messages, those requests won't reach B and they would be lost. So That's bad. So what we could do to handle this is to redesign our application. So again, we would have A and B components, but we wouldn't connect them directly like it was done previously. But what we would do is to add a queue between them. Queue. And then component A would write messages to the queue, and component B will just grab those messages from the queue and process them in its own pace. So component A starts to work, it adds those messages, those bars are messages, and then component B, when it starts processing, it simply grabs those messages and picks them from the queue and works with them in its own pace. So if there is even a heavy load from A, it would just fill the queue, but no message, no request is lost. They will have to just wait until they are processed by component B. Obviously, this approach, it requires some changes in the application. So no longer we would have a synchronous response from B. It would be just like this. So A sends message to the queue and gets a confirmation. Okay, message has been sent. Your order has been received. We are processing it, for example, right? But we don't know actually when it will be processed. It might be in a minute, or it might be in 10 minutes. Depends how fast is component B and how many queues, how many messages are there in the queue already. So you can think of a queue like a kind of a buffer that is used to just buffer our requests. And now, important thing to know is that queues in a storage account, they don't guarantee a FIFO approach, first in, first out. No. Usually it happens, but it is not guaranteed. So basically, there is no guarantee that the first message that was written to the queue would be the first message taken from the queue. No. And basically again, this queue service inside a storage account, it's pretty basic one. If we need something more powerful, we should take a look at the service bus. But again, that's not in the scope of the exam. So let's take a quick look at this queue. How does it look like? So again, I'm in the storage browser. So let me create a brand new queue. And inside this queue, let me add messages. The first message. This is the first message. Like this. Created. Let me add new message. And actually, in this case, maybe it is some JSON file that tells us what order is to be processed. Customer ID. Or whatever makes sense in the context of our application. So message is just a text, so we can put anything we want there. And now to grab messages from the queue, we would just click this in the queue message, and it will take the message from the queue and remove it. So I just simulated component B that grabbed the message and processed it. The same with the second message, and so on. Obviously, in real life, we won't be using Azure Portal to do this, but some APIs. But let's get back to our drawing. So, can we use queues as a data lake? No. They are used to store messages, and we want to store files, so no, it won't work. So, the last service that we have inside our storage account is called file shares or file service. So let's think about this one. File. And now, this one is again pretty easy. It basically is used as a file share in the cloud. And file share is nothing new. We have this for many years in Windows. File share is just a folder or directory that is available over the network. Simply as that. And actually, I could simulate this by using this projects folder. I would just right click on it and use give access to option, specific people, and then I could share it. And now we can see that from now on, I could access this folder by using this network path / Piotr T, that's the name of my machine, /projects. So that's a network name under which this project directory is now available. See, I'm here under network, Piotr T, projects, and I can see the content on this folder. So this is a file share. And basically, this file service in a storage account, it has few use cases. So we might want to use it to replace our on-premises file servers. And file server is just a machine that has those directories shared to various networks and various people. Secondly, if we have a lift and shift scenario, then those file shares, might be a lifesavers. So lift and shift. And basically by a lift and shift scenario, I mean a situation in which we have some on-premises application that was using file share on premises one, and we just want to take it and move to Azure, to the cloud. And we want to get rid of this on-premises file server and use something available in the cloud. And in this case, this file service would be useful. Now, what's next? Those file shares, they can be mounted, which is pretty cool. For example, like this. So I just shared this project folder, and what I could do is to map a network drive. So I could say that, for example, under letter Z, I would like to have my share available, like this. And now you can see that suddenly I have a new drive. I have a new drive on my machine that is available under Z letter that points to my network share. So very simple way to access this data. So that's still possible with file shares. And there's one yet a very cool feature that proved to be very useful in my case, is the file sync. And let me explain why it worked for me. So basically, in the past, I was working in a project which was like this. So we had two locations. Our office was in Poland, and the other office was in some other country. Another country. And we had there quite huge database that was located in a data center in the other country. But what we wanted to do was to, from time to time, just grab a backup of this database, of the production database, and move it to Poland, to our office, to restore it. So we would have an access to real data to test performance, to test new functionalities, to develop new stuff. And to be able to copy this data over the network, we used SFTP approach. That should work just fine, right? But the problem was that, first of all, this database backup was quite big. And secondly, the internet connection wasn't that reliable. So it was often the case that the connection was lost, was dropped. And as a result, the backup of database was not copied over the network. And it was quite a pain in the neck. And actually, one of the best methods to solve this, or temporary workarounds, was to fly to this other country, just take a disk drive with you, copy manually the backup there, and fly back to Poland, because that was more reliable than just copying the data over the network. But that solution wasn't ideal, obviously. So what file shares and file service helped us to do was like this. So we were able to create file shares on both sides, in the other country and in the Poland. Then those guys from the other country would just drop a backup of the database there, and we would configure those file shares to synchronize by using this feature of file service called file sync. So basically it worked that whenever they uploaded or whenever they saved this database backup on their side, it was automatically copied to Poland, to our location. And it was reliable. We didn't have to do anything apart from initial configuration to have this data available. So that was the way we were able to solve this issue of copying data over the network. But again, those file shares, their use case, it doesn't really match what we want to have in case of our data lake. So again, it doesn't work. So why did I say at the beginning that the storage account is the service we want to use? So basically, what we could use is to go back to our Blob service, the one that was the most promising, and convert it to a true data lake. And I will show it in a real life example. So actually, let me create a brand new storage account. And I will show you the option we have to select to have this fully blown data lake. So again, name has to be globally unique. And now, instead of just clicking review and create, I would go to advanced options. And here is the one that we've got to check. This enable hierarchical namespace. So that's the option that turns this regular blob storage into data lake. So that's what we have to do. Very important. So that's the checkbox that we've got to select. Now that will be a data lake. So let me create it. All right. And let's go back to our drawing. So actually, what happens when I selected this checkbox? So basically what we did was to convert this regular blob storage into a data lake. So what we would do is that whenever we want to have the storage for analytics like big data, then that's the solution, this ADLS Gen 2. And ADLS stands for Azure Data Lake Storage 2nd generation. So that's what we just did. Checking this checkbox, converted this regular blob storage into this ADLS thing. And now, so you might think, all right, so it means that this regular blob storage is of no use, right? And actually, it's not. It's not the case. It has some uses, maybe not in our case when we want to have this data lake thing, but generally, the blob storage is quite useful. So for example, when we want to serve images and store them. So let's say we've got some websites that has to display some image and we want to host those images somewhere, then we could use this regular vanilla blob storage to achieve this. Secondly, if we are continue to work with this new YouTube and we want to stream videos from somewhere, then we've got to have some location, some place where those movies would be stored. So blob storage would work quite well in this case. Likewise, if we need some place to store our log files, then this good old blob storage, it would work quite well. But when we want to do some analytics on the data, then we've got to turn on this ADLS Gen 2. So let's think about changes that we just did. So what has this ADLS Gen 2 different compared to regular blob storage? So first of all, its main use case is big data analytics. So basically, analytics. So basically, in 95% of cases, when you deal with big data and you need to store the data in a data lake, then ADLS Gen 2 is your choice, and it's a good choice. Now, you should remember that the regular blob storage, it had this flat structure. We weren't able to create subdirectories. In case of ADLS, Azure Data Lake Storage, we can. So we can have those true hierarchies. Which might sound funny that Microsoft is so proud about this feature, but actually it makes a lot of sense. So let me explain and let me show you an example of those hierarchies. So let's say we have a data lake that we would like to organize in some way to avoid total mess. So let's say that we create a raw container that would be used as a place in which we store our data ingested from various data sources. Then, under this raw container, we might create a SAP directory to store data coming from this SAP system. Then, from SAP, we might ingest different datasets, like sales. So let's create a directory for it. Then, we might want to partition our data inside this sales directory, let's say by the date we extracted it from the source. So we might have a structure like this: year equal to 2023. Then we might have month equal to August. And then we would have our files on a data lake. Or maybe we would like to have even separate directories per days. Then what we might have from SAP is that apart from this sales dataset, maybe we also want to ingest employees. Employee. And again, we would partition it by our ingest date that we would have year equal something and so on, right? Then apart from SAP, maybe we ingested data from some other system that would again have some subdirectories. So you can see that organizing our data lake in a proper way is really important, and having this possibility is critical. And we'll get back to some rules that we should follow when we organize our data, but that's for one of the future videos. So in case of this ADLS Gen 2, we can finally create those true folders. And let me show it, that it really works. So now, if we take a look at overview of our storage account that we created, you can see that this time, here instead of Blob storage or Blob service, we have data lake storage. So it's a clear indication that this storage account has these storage lake capabilities enabled. So let's go to a storage browser, to Blob containers, the same place that we used previously when we were working with regular Blob storage, and let me add a container like SAP, this top level container, top level folder, which is a container. Then inside this SAP container, I can create a directory, and this time it would be a real directory. Previously, in case of Blob storage, we had those virtual folders that disappeared when I went up and down. This time, this folder exists because it's a real folder, not a virtual one. Then inside our sales, I could create yet another folder, and so on and so on. Right? So you can see that here in ADLS, we can have this true hierarchy, true tree structure. That's what we need. And then why would we want to have these hierarchies, those data organized in this or another way? So first of all, to avoid mess. Secondly, to improve performance. So let's say that we are doing an incremental processing when every day we load data just from specific day. And later on, when we want to transform the data, we know that actually we should focus only on this specific file, because that's the file from yesterday, and the rest of them we don't care about. So having this data organized in a proper way would help us to achieve this. Next, security, which is again one of the key features that we listed that a data lake should have. So in case of security, we can be pretty much granular and selective when we want to define who has access to what in a data lake. We might say that specific person has access to SAP folder and everything inside this. We might say, okay, but another person, this person has access only to sales data, not to the employee data. We might be even as granular as to say that someone has access to a specific file only, to a single file. So we have full flexibility here. And finally, if we take a look at a list of our requirements that a data lake should have, we have this Hadoop compatibility listed. And yes, ADLS Gen 2 is Hadoop compatible. Hadoop compatible, which means that it can be used by various big data tools, which is a great thing. All right, so that was it. It was quite a long episode. So basically, what I would like you to remember from this one is that we really do want to have a data lake in our designs, just to simplify this ingest and extraction process, just to be able to dump our data somewhere in an easy way. And to achieve this, we need this data lake thing. And data lake is just a concept. And its implementation in Azure, it relies on this storage account service, inside which we've got to enable hierarchical namespaces to convert regular blob storage into this fully blown Azure data lake service. So that's it for today. Thanks. I hope this was useful, and see you next time. Take care.